So, an introduction to this lab, the goals of this lab is to one, find the distance dependence of a magnetic field of a smaller bar magnet, then measure the magnetic field of the magnet on axis and on off axis using the Biot-Savart law for magnetic fields. We're also going to simulate this magnetic field using GlowScript and then compare the measured magnetic field to the simulated magnetic field on the Python. And some of the findings are listed below. One of the major findings is that the magnetic field magnitude increase as the distance increase, and that the magnetic dipole moment is roughly 2.24 times 10 to the negative 7. The measured off-axis magnetic field is 1.92 times 10 to the negative 4, and the simulated off-axis is 2.56 times 10 to the negative 5. So some of the key concepts of this lab is Biot-Savart law, the magnetic field of a bar magnet, the logarithmic plot, and the magnetic dipole. So when moving into the experimental procedure, first we can look at the materials, which we use a bar magnet, a magnetometer, which is an application that we use to take in the data, a meter stick, and tape. We also had to calculate the magnetic north, was basically placing the phone in orienting it in a way such that the magnetic meter had an x component of 0. We also measured the on-axis magnetic field by measuring the distance between the magnet and the magnometer, where the magnometer is on axis to the dipole axis of the magnet, following the x components of the magnetic field. Then, in order to measure the magnetic field, the off-axis magnetic field, we used the Magnetometer app, measured the magnetic field of a bar magnet. We then aligned the phone with the Earth's magnetic north and measured the field at different distances. We took the average readings of these distances when taking the multiple readings at each distance, and then we continued to repeating those measurements in order to ensure minimal interference. So now going into the lab, some of the assumptions and conditions that we had was that we are assuring that the bar magnet acts as a magnetic dipole. We are assuming that the system is the observation point, which is a magnetometer, and that the surroundings is the bar magnet, which is producing the magnetic field. And going back to number 1, assuming that the bar magnet acts as a magnetic dipole allows us to apply Biot-Savart law to this situation. Now, here's just an example of our experimental data with the graph on the side, showing the off-axis field and then the exponential plot on the side. And now this is our computational model with our data. And some of the results in the conclusion is that the net for the experiment off-axis average was 1.92 times 10 to the negative 4, and the net for the computational model was 2.7 times 10 to the negative 5. And a conclusion that we can make is that the magnetometer measures a magnetic field close to 0 in the x direction when it's far from the magnet. The x component increases as distance increases. The phone orientation relative to the Earth's field affects the measured bar magnet field, and that there's certain points of error that can cause the difference between the computational and the experimental model, including uncertainty in the phone center locations, as tilt, imperfect Earth field subtraction, etc. Now moving into the what if, we can ask the question, what if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How have your results changed? And the results would have changed because the measured magnetic field would be different due to not accounting for the magnetic north. And in the x component, it would be different because magnetic north would continue to the magnetic field measurements, while in the y component, it would also be different because you're not accounting to the magnetic north. Now, the next what if question is, what if you were to stick two identical magnets together end to end and you run the experiment again? How would you expect the measurements to differ? And these two magnets together would cause the magnetic field to increase because it would have a combined magnetic field from the two magnets. And it would approximately be double the magnetic field just because there's two magnets present now, and the distance would decrease due to the increased magnetic field. Thank you.